Ever wonder why stars are so bright, or how the sun produces so much heat and light? It turns out each star is a giant nuclear furnace that releases energy at its core. It's nuclear energy that lights up the sky. The sun is the star that glows closest to the Earth. It gets its energy by burning gases at its core in a process called fusion. Like most stars, the sun consists almost entirely of two gases, hydrogen and helium. During fusion, hydrogen atoms collide with such strong force that they fuse together to make helium. Each second, 600 million tons of hydrogen convert into 596 million tons of helium. The missing 4 million tons of matter are transformed into energy. This process is only possible because of the enormous heat and pressure found at the center of the sun. It's about 25 million degrees Fahrenheit in there. Energy moves from the center to the surface of the sun with dramatic results. The most spectacular sight is an enormous explosion of energy known as a solar flare. These flares send radioactive particles into space. Particles that get carried by solar winds. They reach the Earth in a day or two, where they're deflected by the Earth's magnetic field. But at the North and South poles, these particles can hit the Earth's atmosphere and produce brilliant light shows known as auroras. While not everyone has a chance to see an aurora, all of us certainly experience the sun's energy each day. At 93 million miles away, we are far enough removed from this star to enjoy the benefits of its heat and light. During photosynthesis, plants collect energy from the sun's light and use it to make food. Like every star, someday the sun will run out of the gases that fuel it and gradually fade away. Astronomers believe the sun is more than 4 billion years old and has already burnt up about half of the hydrogen at its core. But no need to worry. It still has about 5 billion more years to go. The nuclear energy that powers every star seems almost inexhaustible, and for that reason, scientists would like to find a way to generate it on Earth. But that's a tall order. It requires them to duplicate and control the same conditions found at the center of the sun. Scientists are working on ways to do just that.